Unfortunately, Karim was not able to attend physically this event. He's supposed to arrive yesterday from London. Karim is a co-developer expert in machine learning, and he's a co-founder of an AI company called InstaD. You can check it online. I wished I would have to see him, or we could see him here physically in that event. But however, he was really keen to do it, and he suggested to make it over the hangout. So I hope you will be able to catch something what you're going to say. If you have any questions, just raise your hand. We'll bring the microphone to you, and he will hear you too. So feel free to engage with Karim session. Karim, go ahead, please. You're on the big screen.
Hi everyone, thank you for having me. I really wanted to attend in person. Unfortunately, I couldn't make it, so I'm quite excited actually to be discussing AI and machine learning with you guys. And I have to say it's the first. I've never had a video conf presentation, so that would be interesting for me too. So as Mohammed has mentioned, so basically, I'm coming from the machine learning and AI world. I'm a Google certified expert in that area. 4 years ago, I co-founded InstaD. So basically, 4 years ago, I was maybe like some of you today wondering, what's the potential of AI, how I can deploy AI into what I do. And fast forward 4 years, there are lots of interesting things happening, and this presentation is meant to provide you with an introduction to the field and get you a sense of what's possible. So we're not going to get too technical. This is meant to be an introduction, but we're going to see pretty cool stuff. So let's jump right in. So I'm going to share my screen and have it here. Yeah. So 1 second. Yeah. So let me do that. Share the entire screen. So, do you guys see the presentation now?
No. Yes.
Great. Okay, excellent. So, today we're talking about AI, machine learning on Android and TensorFlow. So, the first thing to discuss is really like what is all this about? There's a lot of hype with AI. I think it's quite important to have a clear sense of what it is. So, the goal of the first part of this presentation is get you a sense of what is AI today. So the best definition, if you want, that I found out was the one from David Silver, who is the lead scientist of Google DeepMind. He's basically saying AI is the combination of two technologies. It's reinforcement learning on one side and deep learning on the other. So these are really like the two things that are happening. The combination of both is modern AI. So what does it mean, really? Reinforcement learning is the way computers are gonna try to learn by doing. So like, you figure out stuff by doing it. Like if you play a game, you're gonna try several times, win sometimes, lose sometimes. Deep learning is the ability to perceive. It's the ability to figure out patterns into things. For example, like you see an image, you figure out, is there a person in this image, is there an object? So this is linked to perception. So while both together is modern AI, because deep learning fundamentally is about sensing the world, feeling what's happening. Reinforcement learning is about acting on the world. It's about doing, it's about trying things and figuring out what works and what doesn't. So one is perception, one is action, and together this creates the possibility for smart systems. So interestingly, actually, the MIT Technology Review had promoted these two technologies as two breakthrough technologies in 2013 and 2017. So deep learning, they said this is one of the top 10 breakthrough techs in 2013. In hindsight, they called it pretty right. Reinforcement learning, they said this is the breakthrough tech last year. And even in the 2018 list, which came out like a month ago, there were like 3 AI technologies. So you can sense something is really happening in AI. So let's get a bit deeper into what it really means. So deep learning is really about going from very low level information to progressively abstract concepts. So So how does it work? So if you see here, by the way, do you see my screen mouse? Like, do you see it on screen?
Yes.
Perfect. Okay, so let's take an image. And historically, like, AI owes a lot to vision. During the last AI winter, it is actually convolutional networks in vision that saved AI, if you want. So this example is actually historically relevant. So, as you know, an image is really, for a system, just a bunch of pixels. So variations of intensities and lots of them. So, and a deep learning system basically is going to be able to take these pixels, as you can see here in the image, at the very low level and try to figure out variations of intensity. For example, like here, or maybe this area is a bit more white, here it's black, maybe this is like, looks like a line, which is like different intensities continuously moving around the line. So at the basic level, it's going to try to figure out very simple stuff, like edges, for example. But once it has edges, two edges make a corner. And so progressively, you're getting a higher and higher level of abstractions to the point, and this came up as a surprise for certain people, that you can define really like abstract objects, like a person, a car, an animal. When you think about it, this is pretty impressive because no programmer, no engineers can manually hardcode an algorithm to say what is a person or what is a car. Yet deep learning systems can do that. The operations are very simple. It's just a bunch of multiplications and additions. But using mass computation and using this idea of multiple layers of abstraction, so it's like what you figure out feeds out what you're going to figure out next, which is more abstract. That's the deep part in the world of deep learning, if you want. You get to a point where you have applications that can be used in the real world, and you guys know that there's a lot going on with visual AI, from self-driving cars to lots of other applications. So what is interesting about technology is that it really works in practice. And today, modern AI systems are better than humans at vision. That sounds a bit crazy, but it is the case for now 2 years. The best AI systems actually can perceive and see better than humans. So it is a revolution happening there. Now, this revolution has been fed by three things, really. As you know, a lot more data, and most importantly, data which is high quality data, which is organized and which is labeled, has been instrumental into the growth of AI. I would cite in particular the ImageNet conference, which is, so what I was saying is really like AI is progressing exponentially because every one of its components is progressing exponentially. So data availability and data production with all the mobile phones, with all the IoT devices that we have, that's really growing exponentially. But it's the same thing with the GPUs and hardware in general, thanks to Moore's law. And surprisingly, the algorithms themselves are also progressing exponentially. So that creates a triple exponential for AI progress. So in particular, on the algorithmic side, that we have had tremendous progress with reinforcement learning. So remember, we had said AI is due to reinforcement learning and deep learning. So that the part about reinforcement learning has been absolutely impressive. You guys have certainly heard about progress in solving Atari games, as you can see on the right side of the screen. Do you see the animations? Yeah. Yeah, perfect. And one of the amazing things AI has done recently, for example, was in the game of Go, which is on the left here, but also in the game of chess, being able to learn to become a master at the game from scratch. So Google DeepMind in December basically trained an AI system in only 4 hours to become the best player in history of chess. And when I say in history of chess, it's both. It beats all the human champions, but we know that since the Kasparov and the Deep Blue 20 years ago. But it also beats all the specialized programs of chess, like the software champions at chess. So there is a lot of potential out there. Now I'm going to talk about AI tomorrow, because what is interesting is it's not only like where we are today, but what's the potential. And as I said, things are growing exponentially. So if I come to this slide, I told you AI is the combination of these three components. Surprisingly, actually, AI can accelerate these three components themselves. So how can AI accelerate data? Really love these breakthroughs here, and I'm very excited to share this with you. So on the left, you see art pieces which have been essentially, modern art which has been manufactured by AI system. What's interesting here is actually people tried to show to people like, do you think this is a person who did this or an AI? And that's the test here on the low side, and they couldn't figure it out. Like basically, they couldn't guess better than random. So that was pretty impressive. This happened last year. Research from Al Gamal and all, and she was presented at the NIPS conference. With AI today, you can have actual creativity. So let me ask you a question. Out of the two photos that you see in the big screen, like the lady and the gentleman there, which one do you think has been created by an AI? Left or right? What do you guys think? I didn't hear your answer, but I can tell you something. Both of them have been created by AI. So basically, these two people do not exist. And what's absolutely incredible is these are high-resolution images. As you can see, they're very high resolution. They're actually 1024 by 1024 pixels. So think about it, that the system is capable actually of digesting information to the point where it can recreate really a human face is very complex. Making a realistic human face sounds like an impossible task, yet that's where we are, and this is research which was published only 4 months ago. Same thing with anime characters that you see here on the top right. You can now create anime characters, you can animate them. So in terms of mobile apps, there are tons of things to do with this. Like you could take data and reimagine it in many ways. Like think about all these apps where I take you a photo, I show you the same person, younger or older, and many other things. So you can unleash a lot of creativity and basically have AI boost data, like create synthetic data which is so good that you can figure out that it wasn't, that it was AI made. It's the same thing when it comes to manufacturing GPUs and hardware. So I'll just go very quickly through this slide, but this is just to tell you that modern hardware and software makers now use AI even at the design stage of their systems, and these now operate better than experts. So if you want, it's like a game, like we saw before, it's like a game, except that the game here is to manufacture a great hardware. And we typically, on this particular one, on device placement for GPUs, the Google Brain experts got something which was 20% faster than GPU expert, which is really pretty awesome. So AI is boosting hardware. So the second component here in what is driving this progress in machine learning. But what is probably the most surprising piece of all is that actually AI also is generating new algorithms. So new algorithms, that's surprising too, but these are state-of-the-art results. Few people know about these results, but basically something like a month and a half ago, Google Brain, which is led by Jeff Dean, which just got recently promoted to global head of AI at Google, showed that an AI system can build child machine learning systems, and that having an AI manufacture machine learning models can get you better results than experts. That is a very surprising result. And importantly, this can happen very quickly. Like you can actually get results in 1 day. This is a new breakthrough of immense magnitude, and I invite you to look into these things because it could impact what you could do, it could impact your potentialities. What we are saying here is you don't necessarily need to have PhDs to be able to use advanced AI. For example, Google has just released a system called AutoML that is allowing you to do this on the cloud on your applications. Are you guys there? Yeah? Yeah. Okay. Cool. And so that is that is pretty impressive on its own, but what is also impressive is the speed at which improvements come. So the results you see here, these were from last year, like the top 2 in the table. To get these results, basically Google employed 800 GPUs, which is really like a lot of compute power, and for 20 days. In February, so a month and a half ago, basically they employed 1 machine for less than a day to get results which are comparable. So this is essentially 1000x speed up in 1 year. So, you know, when we talk about Moore's law, we talk about like things improving, like doubling, like compute power doubling, for example, in 18 months. Here you have 1000x speed up in a year. So the message I want to convey here is it's a necessity to be to use machine learning into your products, because otherwise other people will do it and they will typically have better performance. And these things are accessible. This is also the message. Like, you don't need to be a PhD in machine learning to do it. I invite you to have a look, for example, at AutoML, which is going to be released soon by Google to the large public. It is in a private beta at the moment. These things are very powerful. So, in the future, this is actually a slide from Jetty, from Google Brain. You could really ask very complex questions to AI, like which of these eye images show symptoms of diabetic retinopathy. That sounds like very complex, but actually Google Brain already released results on using eye pictures to diagnose some forms of heart disease. So it is happening. Describe this video in Spanish. Fetch me a cup of tea from the kitchen. Things like this, which sounds very human today and absolutely impossible to do for an intelligent system, will at some point be reachable by modern machine learning, which is progressing exponentially. So this is to give you a sense of what's happening. It's a very exciting field at the moment, and really, like, I invite you to dig into it, and do not believe that because you're not an expert, you cannot learn. 4 years ago, I was with, like many of you in the room, curious about AI, but not knowing necessarily how to tackle it. And I can tell you that it is possible to learn and develop in this field. Now let's talk a bit more about TensorFlow and mobile. So why on-device machine learning? It's good because for multiple reasons. First, you don't have server calls. So if I can run on my phone, this is a lot faster. I don't need an internet connection, and I don't depend on internet connection, not like me today, for example. So that's good. It also works offline, which, you know, in locations which are impacted by, you know, low coverage or bad coverage. That is very key. Think about, for example, like healthcare in Africa. If you had machine learning on mobile who could deliver that, that would be absolutely awesome. The data stays on device. This is fairly important for privacy, and as you know, there is, you know, if you follow the news, there is a lot of, you know, important matters being discussed on that at the moment. It's also power efficient. Like, if I can run everything on a mobile, power, like, you know, by definition, it's power efficient because it needs to be run on mobile. And I have all sensor data. I have, you know, basically, you know, movement data, sound data, text data, image data. So there's a lot that I can pull up there. Only problem is it's pretty hard. You know, you have tight memory constraints. Energy usage is definitely, you know, an issue. And of course, you know, you have very limited compute power that can fit on a mobile phone today. But the good news is that, you know, Google has just released TensorFlow Lite, and this is also the goal of my intervention today, is to tell you that, you know, there is now a format which is called TensorFlow Lite, which enables you to convert even complex machine learning models that you have developed with TensorFlow, for example, into the Lite format. So you can take a model that exists in TensorFlow, convert it into Lite format. And this Lite format will enable, you know, running operation kernels, having hardware acceleration delegates on the phone. So it's a pretty advanced piece of technology, and it is cross-platform. So it obviously works on Android, but it also works on Raspberry Pi and other things. So you can experiment a lot with this. And this has just been released 2 weeks ago at the TensorFlow Dev Summit. And I think this is a very interesting development because it makes machine learning a lot more practical and deployable. It also makes machine learning fast. If you look, for example, like TensorFlow Lite, because it kind of skips operations that are not needed. For example, like if you're running on images, you don't need to have like 64 decimals into your computation. You can run at 32 decimals or 16 decimals. So this is what we call quantization. Because of that, you can basically run machine learning models faster with TensorFlow Lite, and because they are fast, they can then fit on a phone. So it's pretty groundbreaking what's happening there. Google is going to release multiple apps soon on that front using TensorFlow Lite, so portrait mode, where you'll be able to manage photos better. Google Assistant, of course, is available, and this is a very powerful piece of technology. And also Smart Reply and Google One on watches and phones. So these things are happening, but it's an exciting time because these things are also accessible to you. It's an open platform. All the investments that Google is putting, and these are more than hundreds of millions of dollars, are actually accessible to you for free. So this is really an exciting time to be a mobile developer on Android, actually. And the interesting thing also is that the TensorFlow platform is the most popular online, so it's not just Google. There are lots of other people who are contributing time and effort to make the platform great. It's by far the most widespread machine learning platform today. That is important because it's a little bit like the story of Android. If there is a huge ecosystem, it makes the system a lot more valuable. So now I'm gonna, before we finish this presentation, I'm gonna actually show you a little bit how you can build an AI model on mobile. The problem is very often data, as you know. So you could say AI is a big hammer and data is the nail, and AI is kind of like a hammer looking for a nail, like how can I build data? So let's look at an example of visual AI. So like, how could I quickly build a visual AI tool? Let's say I want to recognize thousands of products. I have no data, I have no model, I am stuck, but I still want to do something. Like I want to recognize, for example, that Pringles box, which is a pretty cool one. So how do I do that? So actually what is interesting is you can actually build data sets yourself to a point where this becomes manageable. So if I take the example of the Pringles, so do you see the Pringles box on the left, guys? Yeah. Perfect. So if you see that Pringle box on the left, I want to train an AI system to recognize that Pringle box. So if I have one photo, if I turn it around, make rotations, it's still a Pringles box. So from one picture, I could create lots of other pictures which are still the same object, rotating it, changing the background again. So if each picture can generate 20 augmented pics. Typically in machine learning you need something like 6,000 pictures per product. So in reality you only need something like 300 pictures that you are taking. So if you have a team of like 30 people, that's only 10 pictures per person. So you could do it in one day. And then you have tools online to rotate, turn, change the background, etc. So right there, bam, you have basically enough pictures to build a machine learning model. The good news also is you don't need to train a model from scratch. Actually, when it comes to vision, if you remember my first slide in the beginning, I said it goes from very low level pixels to high level abstract concepts. Actually, if you're training your system to recognize Pringles, even if it was trained to recognize other objects, the first steps that it does are pretty much the same because it's about recognizing pixels, recognizing lights. You only need to train the end part, which is classification. So this is a concept called transfer learning. Like I have a model that trained on something, but I can transfer it to something else. So that's possible. And you don't need to be an expert again. If you can do it on the Google Cloud, it's already there. You don't need to dig into the details, but I'm just trying to convey a sense of, how these things work and why it's exciting. So as a consequence, you can really build a model which is very powerful. So I'm going to show you now a demo of what this can do. So this is the demo from last year. So literally, you can in real time recognize what people are picking up here in a store. Do live inference with this. And because modern AI is advancing so quickly and you have powerful tools with TensorFlow Lite, it opens up a whole set of new opportunities, even on mobile. So it's pretty impressive when you think about it. Here, in real time, you can recognize that person took a date, that person is taking a shampoo, etc. So sky is the limit really on what you can do. This was a demo from 2017, mid 2017 from a company called Standard Cognition. And it was considered really like a breakthrough at the time. Like you see, like even they throw objects and it really follows it, the ketchup bottle and stuff. So today, this type of technology is not very far from you guys. And I really encourage you to dig into TensorFlow Lite, dig into what's possible, because, and that's maybe my conclusion, AI already works today. Like it is delivering results in speech, in vision, self-driving cars, natural language processing, chess, anything you can imagine. But importantly, it's not just about what it does today. AI, accelerating AI with creativity on data, better hardware, better models, that means that there will be a massive gap opening up between people who use and deploy AI systems on mobile and on any other sorts of devices, and the ones that say no, AI is too complicated, it's not for me, like I'm not part of it. So that gap is going to accelerate exponentially. And my message today is it's really possible for you guys to build advanced application on mobile. You do not need to be an expert. All the tools are there, and people at Google, at other tech firms have spent an incredible amount of time to make this technology simple and accessible through cloud, but also through mobile, even without internet connection. You can experiment and deploy applications which even a year ago would have been considered absolutely impossible to build. So I leave you with this message. This is a very exciting time in terms of like AI machine learning today, but do not believe that this is something which you're not part of. You can definitely be part of, and all the tools are there. The real limit is your appetite to learning and building things, which I'm sure is very high. So I'm very excited by what you could potentially build. If you have questions, want to stay in touch, this is my contact information. But really, thanks a lot for inviting me. I hope you found this session useful, and we're happy to take some questions now.
Yes, let us see your face, please. Yes, Karim is here.
Yeah.
So, ask questions. Guys, question? I mean, Hangout, you can ask questions also.
So
yes, here we have one.
Yeah.
There was a point that you mentioned.
Wait, I bring the microphone because I'm not.
There was a point that you mentioned about some of the limitations on the mobile devices. Could you just go over that again, quickly?
What is it? The limitation of mobile devices? What is the question?
You said TensorFlow Lite was introduced to overcome the limitations on mobile devices.
Yes.
So if you could just go over those limitations on the devices and how possibly the advancements in the mobile device technologies are also trying to catch up with AI. If you could share some thoughts on that.
Sorry, I don't hear you very well, but in general, what I would say is that we are starting to overcome, say, the biggest limitations in terms of deploying AI on mobile. So it is possible now to, for example, like this visual AI system that I showed you, you could definitely deploy this on a mobile today without internet. The progress in computing hardware, which is in the cell phones themselves, makes it possible to deploy these systems. So I would say, compared to where we were even a year or two ago, at the time it was very hard to build an app that incorporates AI. I would say today the field is really open, and you could get there very quickly.
Thank you.
Another question? Nothing in mind?
So
we have two questions.
Yes.
It comes.
Mohammed, if I don't hear very well, maybe you can repeat the question after that. Yes. In case I don't hear very well with mine.
Can you hear me?
Can you hear him? No.
No, I cannot hear him.
Can you come to me so you can speak here for the show? So if it's complicated, it's easy, I can repeat it. I have just 5 second memory.
Can you hear me now?
Yes.
So I started studying machine learning, I think 3 times. So far I always gave up because it became a bit too much mathematical, and it was too hard for me. I gave up. Would you suggest instead to jump straight on TensorFlow instead and learn and use the model that already prepared to start using it?
Yes, I think it's possible if you have a software developer background, a mobile developer background. I believe that today it is possible to deploy machine learning programs without not knowing much about the math behind it. So if you are a bit curious, there is a program called 15-hour crash course on machine learning, which is done by Google, which is meant for beginners. So you can try that if you're curious. But you do not need to know advanced mathematics to deploy these tools. So you can deploy Google Cloud, check TensorFlow Lite documentation, check the examples. With that you can. So why do I tell you that you can? My co-founder Zora, she is a developer, and she is not from a mathematical background. She actually did literature. And she managed to build mobile apps using AI. So definitely it is doable, and do not spend time on reading complex mathematics books if this is not what you love, and if you're more like a software person, you can jump right into TensorFlow.
Thank you.
Thank you. Okay. There was a question, I think.
Yeah.
It's simple.
Simple, 5 second demo, yeah?
What's the difference between machine learning and deep learning?
What's the difference between machine learning and deep learning?
Yes, so very good question. So machine learning still requires an engineer in the following way. In machine learning, you are typically saying, okay, I'm creating this feature, this feature, I think these features or these variables explain the data very well, and then I'm going to train a model on it. The very big difference with machine learning, with deep learning, is in deep learning, the features are created by the algorithm itself. So you are really feeding raw data. Like you remember in the beginning of the presentation when I told you we're going straight from pixels to concepts through all this multi-layered process, there is no human intervention in the loop. So that is the difference. Like deep learning system can create their own features, and actually for you guys, since most of you come from a mobile development angle, it's easier to deploy machine learning, deep learning systems than machine learning systems, because you do not need to get into the mathematics. The system will do it for you. It's all about like gathering the right data and deploying the right systems, but you do not need to dig into the mathematics so much. So I think deep learning is actually very good for a software engineer.
Thank you, Karim. We have another question, a fourth one.
Yes.
I saw the 3 seconds.
I will let you.
Yeah, okay.
Can you hear me?
Yeah.
Yes.
My concern, I have a question about the security aspect of the model on a mobile. Say, I have a proprietary, I have a private data on which I have trained a TensorFlow model, and now I transform it into TensorFlow Lite, and it is on mobile. Now, someone decompile the app and get the model outside easily. So is there a way I can encrypt the models or make more secure with respect to the models and as well as data which is playing around the mobile?
I understand. Well, this is a very good question, and the answer is yes. There is a code which is, this is a recent breakthrough in cryptography and machine learning. But today, you can actually encipher the data on your mobile or wherever it is, encipher the model, and have both of them train in enciphered mode. So you will not, the person that trains will not see the model, and the person that has the model will not see the real data. So how is that possible? It's possible because of a new technology called homomorphic encryption. So as you remember when in the beginning, like that slide about pixels and photo going from pixels to high-level data, it's just a glorified bunch of multiplications and additions, like millions and sometimes even billions of them. But a crypto system that can preserve addition and multiplication will enable training in unciphered space. So this technology exists, and feel free to send me an email. I will send you the links. There is a very exciting GitHub repo on that, so happy to share with you.
Sure, thank you.
Thank you. Fifth question. I'm here today.
Hi, I'd like to ask you the landscape of face identification in TensorFlow. I'm doing a project using Microsoft's Azure Cognitive Services, and it has a limit of only 10 faces per image. So does TensorFlow offer more than 10 faces in an image for identification, not recognition?
There is no limit, because the beauty of TensorFlow is open source. So if you download it and build up your own model, you can train a model to recognize 100 faces if you have 100 faces in an image, provided you have enough, the image is not high resolution. So what I'm saying is the beauty of this open source framework is that you have no limitation whatsoever. So yes, you could go beyond 10 faces, no problem.
Okay, thank you.
Some governments actually use this on a mass scale and can recognize up to sometimes like multiple hundreds of people in only one high definition image. Yes, there is another question.
Yes, another question.
Hi. So in the field that I'm working in, accuracy matters a lot. So I work in the manufacturing industry, and we're using TensorFlow. I was thinking of bringing it into mobile, but we really need to predict things at the scales of microns. So with TensorFlow Mobile, there's this quantization that happens, which might reduce the accuracy of our predictions. So one other way probably to approach it is to increase the model capacity, maybe having more layers or more hidden units. But what's the better trade-off? Is it to have a higher quantization bit level, or to have a deeper or larger model, in your opinion?
Yeah, so the good news is that you have already in TensorFlow Lite and TensorFlow some of the most advanced models. So you have Inception before, there was V3 for a while, but you have before now. You have also ResNet. So these are state-of-the-art models in vision. So that's the thing. Now, in terms of quantization, does it really degrade accuracy? I do not believe that it degrades it a lot, but you need to experiment. So if I were in your shoes, I would try one of the best that are there, for example, like ResNet or Inception before. They have been adapted to TensorFlow Lite. If you see my slide where I told you, this slide where basically TensorFlow Lite can run inference much faster. So I do not believe that you would have a significant downgrade in terms of the quality of the results just because you're using it on mobile. But obviously it's about experimenting. But like from a fundamental point of view, I think it's possible to have a high quality image detection on the mobile.
All right, thanks.
Thank you. Any question? So Karim, I think we are done. Thank you so much for joining us. Thank you for trying to make it happen. And if they have any further questions, I'm going to share them the slides, the last slide that you have done. So they will contact you directly. Thank you so much for
don't hesitate to be in touch. I hope you found this presentation useful. Sorry, there was an internet breakdown at some point, but this is why, by the way, we need actually application on mobile to be on mobile without internet.
That's right.
So thanks a lot for having me, and it was a pleasure interacting with you guys, and I'm reachable. Don't hesitate to get in touch if I can help you. Thanks a lot, and have a